Hello, my name is Professor Adrivan, and this is episode 18 of the Quadratic series. In this episode, we're going to be talking about graphing quadratics that are in vertex form. Like always, we're going to be doing 3 examples in this video. The 3 examples are on your screen now, so if this looks like what your homework problems are, then this is the correct video for you. If you're looking at these and you're confident that you can graph these by hand, then I would recommend going to the next video in this quadratic series. But for everybody else, we're going to go ahead and jump into it. So with the vertex form, and this form might look kind of familiar because it's built using completing the square. So instead of solving using the completing the square, we can get into this vertex form using completing the square, and that's something that we're going to talk about in the next episode. But for now, graphing it. This form, vertex form, is very beneficial for finding one thing, the vertex. So this form has what we're going to call the H and K. Alright, the H is on the inside in the parenthesis, and the K is on the outside of the parenthesis. The vertex is going to be at the point H, K. Alright, so if we look at this, I have a 4 and a 3. Now you might be looking at this and thinking, well, that's a negative 4. And the way I want you to think about this right now is that this H is going to be opposite. So if we see a negative in here, that means that it's going to be a positive 4 here. Just like if this was a positive 4 in here, we would say that the vertex is at negative 4. And we'll get more into that later on in this video and even more in the next video. So our vertex is going to be at negative 4, 3. So we can plot that negative 4, 1, 2, 3, 4, and up 3. Right here. To find the x-intercepts, all that we need to do is set this equal to 0 and solve like we would do at the end of our completing the square. So if I set this equal to 0 and solve plus 3, we can subtract 3 from both sides. And then we can take the square root of both sides. And here we're going to be taking a square root of a negative. So when we did this in the completing the square video, we would say that there's no real solutions. And this just means that this parabola does not touch the x-axis. There are no x-intercepts. Alright, so let's label what we know so far so we don't get confused. We have a vertex at negative 4, 3. We have no x-intercepts. To get the y-intercept, we need to expand this out. Meaning I want to look at what's going to happen if I square this last term in the parenthesis and then add this term on the outside. I don't need to expand the entire thing out and figure out how many x squareds I have and how many x's I have. I only care about the constant at the end because that's going to be my y-intercept. We know that because it's going to be the c term, the constant term, and we know that from the standard form video that the constant term is the y-intercept. So if I look at what happens when we would expand this out, what our constant term is going to become, if I take negative 4 and square it and add 3, we're going to have 16 plus 3, which is 19, not 0. So my y-intercept is 19, all the way up. I don't think I'm even going to be able to fit that on here. So it's going to be up, 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 very high. So how can I make a parabola? How can I connect my vertex and this y-intercept and get an accurate graph of the parabola? So normally we need at least 3 points to make a parabola. Well, we're going to leverage this idea of symmetry and our axis of symmetry. There's the vertical axis of symmetry that goes through the vertex. If I have a point at 0, 19, the y-intercept, there should also be, which is 4 away from the axis of symmetry, there should also be a point on the other side that's the same height but is also 4 away to make sure that this is symmetrical. So 1, 2, 3, 4. I'm just going to put it right here. Okay, so we leveraged the fact that parabolas are symmetrical, and we took 1 point, in this case the y-intercept, and we kind of reflected it over across the axis of symmetry to give us 3 points so that we can accurately sketch what this parabola looks like. So in this case, we can just connect these 3 points. And we have a good enough sketch. I would take something like this as long as it's nice and curved and it's going through all the points. I would definitely take that for my students. We want to make sure that we label the rest of our information. So we have the vertex and no x-intercepts labeled. We can label our y-intercept as 0, 19. Our axis of symmetry, AOS, is at x equals the x value of the vertex, so x equals -4. Our domain for parabolas is always, always, always all real numbers, or -infinity to infinity. And the range, because this parabola is facing up, is going to be from the y value of the vertex 3 all the way up and up forever to infinity. Alright, so I have a sketch the parabola, I have all of the relevant information labeled, and I have all of the supporting work to show it. So let's try another example. So this is in vertex form, so the first thing I want to find is the vertex. So the vertex I know is going to be the opposite sign of this inside number, and then this outside number. So the opposite sign of +1 is just -1, and then this outside number is 6. So -1, 6 is my HK, it is my vertex, so we can go ahead and plot that. -1, 1, 2, 3, 4, 5, 6, right about here. Now we can set this equal to 0 and look for any x-intercepts that we might have. So we can move the k term, the term that is being added to the binomial, over across the equals. So we have -6 equals -3 times our binomial squared. And then I can divide by this -3 constant. If we do that, -6 divided by -3 is +2. And to get rid of the squared, we're going to take a square root of both sides. I know that if I take the square root of 2, I'm going to get a decimal, not a whole number. So we're going to leave it as the square root of 2. But we are taking the square root of a number, so we're going to write plus or minus the square root of 2. And to get x by itself, we can just move the 1 across the equals. So we have x equals -1 plus or minus the square root of 2. Now we can estimate the square root of 2 to be somewhere between 1 and 2. So if I take -1 and I add something that's between 1 and 2, I'm going to end up with something between 0 and 1. So I'm just going to estimate and put a point there. And if I take -1 and I subtract something that's between 1 and 2, I'm going to end up with something a little bit bigger than -2. So right there between -2 and -3. Because this is just a sketch, that is totally appropriate. I can just put a point that is the best estimate, and I'm going to have the x-intercepts labeled over here so that we have the exact points that they are. So we have -1 plus the square root of 2, 0, and -1 minus the square root of 2, 0. Alright, to find the y-intercept, I need to expand this out and look at only the constant term. So if I'm expanding this out and only looking at the constant term, rather than foiling out this binomial completely, I'm just going to look at what happens if I take 1 squared. And then this negative 3 would get distributed to all 3 of my terms that I would have after squaring this binomial and foiling it out. But I don't care about the x squareds, I don't care about the x's, I only care about that constant term at the end. So after I do 1 squared, I'm going to multiply it by negative 3, and then we're going to have to add 6 to it. Okay, if that's confusing, you are more than welcome to FOIL this out completely, distribute the negative 3 and add 6, and basically convert this into standard form so that you can figure out what the constant term is. Okay, I'm just trying to minimize the amount of work that we have to do because there's already quite a bit. Alright, so 1 squared times negative 3 gives us negative 3, and adding 6 gives us positive 3. So we have a y-intercept at 0, positive 3. We can go ahead and label that 0, 3. Alright, so we have everything. We have our x-intercepts, we have our vertex, we have our y-intercept. We can go ahead and sketch as best we can the parabola. We also know the axis of symmetry is a vertical line going through the vertex, so it's going to be x equals the x value of the vertex, in this case x equals negative 1. We know that the domain of every parabola is from negative infinity to infinity, and we know the range in this case, because this parabola is facing down, is going to be from negative infinity all the way up to the y value of the vertex, negative infinity up to the y value of the vertex, which is 6. We have all of our relevant information labeled. We have a sketch of the parabola made, and we have all of the supporting work shown. And as a quick reminder, if things like domain, range, axis of symmetry, if those are kind of confusing you, there was a video a few episodes ago talking about all the properties of a parabola. Alright, we have one more example that we're going to look at. And we're going to do it the same exact way. So I'm going to start with vertex, the opposite sign of the number on the inside of the parenthesis, so negative 2, and then the number on the outside of the parenthesis, negative 5. We can go ahead and plot that, negative 2, negative 5. Perfect. Now we can go ahead and try to find if there's any x-intercepts. So we can set this equal to 0 and solve for x just like we would solve at the end of completing the square. So we can move this 5 across the equal by adding 5 to each side. So we have 5 is equal to 1/2 times our binomial squared. To get rid of this fraction, 1/2, we can multiply both sides by the reciprocal. So I'm going to multiply both sides by 2. So we get 10 is equal to this binomial squared. And to get rid of the square, we take the square root. Just like in the last example, the square root of 10 is not a whole number. 10 is not a perfect square, so we're just going to write plus or minus the square root of 10 is equal to x plus 2. And we can isolate x by subtracting 2 from both sides, so we get x is equal to negative 2 plus or minus the square root of 10. Alright, so 10, the square root of 10 specifically, is between 3 and 4. How do I know that? Well, 3 squared is 9, 4 squared is 16, 10 is between 9 and 16, so the square root of 10 must be between 3 and 4. So if I take negative 2 and I add something between 3 and 4, I'm going to get something that's between 1 and 2. And if I take negative 2 and I subtract something that's between 3 and 4, I'm going to get something between negative 5 and negative 6. And just like in the last problem, having these points estimated is fine because we are going to label what the x-intercepts are over here. Our x-intercepts are negative 2 plus the square root of 10, 0, and negative 2 minus the square root of 10, 0. To find the y-intercepts, we are looking at taking the last term in the binomial and squaring it. So 2 squared. And then I want to multiply the coefficient in front of the binomial by this answer, and then add my constant term on the outside. And like I said in the last example, you are free to FOIL and expand this out completely. So 2 squared is 4, times 1/2 is 2, minus 5 is 3, negative 3. So negative 3 is our y-intercept, 0, negative 3. We have our x-intercepts, our vertex, and our y-intercepts. Let's go ahead and try to connect these dots. Okay, we just have a couple things left that we need to label. We have an axis of symmetry, our vertical line that goes through the vertex. So the axis of symmetry is x equals the x value of our vertex, negative 2. Domain, always, 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 negative infinity to infinity. And range, because our parabola is facing up, is going to be from the y value of the vertex, negative 5, all the way to infinity. We have all of our relevant information labeled. We have a sketch of the parabola, and we have all of the supporting work shown. Alright, so that's it. That's how we graph parabolas that are in this vertex form. If something didn't make sense and you still have a question, go ahead and comment it down below. If you have a suggestion for something that you would like to see me cover, go ahead and comment that as well. If this video helped you, consider giving it a like and consider subscribing for more math lessons. Thanks, and we'll see you in the next one.